applications as a service. We have Rajan Yadav, Harpreet Gandhi, Hitesh Chabra, and Madhur, myself, talking about how we can use our current existing technology to monitor cloud applications. So what's the goal here? The goal here is we do have infrastructure monitoring, but when you have SaaS applications, how do we monitor the different components? This is becoming more critical because of a lot of applications going towards microservices architecture. For example, we have the NSP platform. Other than machine-centric monitoring, we want to monitor some of these highly dynamic service-oriented architectures wherein different open source components interact very tightly with our own homegrown components. Now we want to monitor all of them because when you have a slowdown, when you have a high latency, when you have an issue, it affects all services. A lot of these issues can be taken whether they are in a private cloud environment, a public cloud environment, or in our case, hybrid cloud deployments. And with these kind of services, because they're all containers or they are SaaS based, we need to make sure that horizontal scalable applications can also be easily monitored at the service level. Now this is an overall view of our application. So we do have different SaaS applications, but our own mass server with a UI that we did with Python, Flask, and ext.js, that sits in a different area. For now it is in a different VM, but we also have different containers which will monitor the service. We'll explain the detailed components as we go along. Now we have used a lot of open source tools for this. One of the prominent one is what is called Prometheus. Prometheus is a very fast growing open source service monitoring system. It was written in Go by a couple of Google developers in SoundCloud. What it offers is a multi-dimensional data model which helps you to cut, splice, and dice metrics based on endpoint, based on IP address, name, and things like that. It has it does the time series data collection during a pull model or HTTP, so it works with a lot of REST interfaces. Now, if you have a quick running service, you can also have a push gateway so that you can pull it for ephemeral services as well. It has a very strong, flexible query language to do a lot of what-if scenarios, to do a lot of queries across services, across endpoints, and aggregate and sum and things like that. They do have an alert manager which can do alert rules, and it has a bunch of exporters provided by them, by the open source community, for all the different components that you can see like this for Redis, Zookeeper, JMX, RabbitMQ, and things like that. Now, we are also using Grafana. Grafana is a very powerful graphic front end. It does a lot of rich graphic and styling, as you can see. It allows for interactive dashboards. It has a very strong REST API. And so we were able to use the REST API to configure the dashboards from the backend. So that helps us in our NAS service. Now, what are we using here? Now, we are using a virtual testbed deployment platform that we call as SP-Task. And basically what this does is it implements the entire vCloud Air Praxis management stack on a bunch of VMs. Actually, those VMs are deployed on the Nimbus framework. And these services are deployed as containers, as Docker containers. Now, they use a lot of open source, components like Cassandra, RabbitMQ, MongoDB, but there are also a lot of internal services like the service controller, the object-oriented as a service broker, the IAM service, the DNS service broker, and things like that. And of course, along with the VMs, the VC and the VCD is also deployed all as containers. And this is very powerful going forward in the CI/CD deployments. Now, what have we done other than integrating the open source tools that we talked about is we have a Python-based REST service using Flask. Now that has a bunch of deployment scripts which can pull in the containers based on the kind of services which are there. It can deploy them and it can tear them down based on the subscribe, activate and deactivate and unsubscribe workflows. There is a very good UI using ext.js which follows the same workflows, and it takes in the config.json as the input. So whatever SaaS application that you have, if you can give us the config.json, we have made it work with our in-house SaaS application, but it could be very useful, very easy to adapt it for any given JSON file. Now it also has, we have instrumented some of the exporters which didn't exist as containers. So they existed as client libraries. We converted them into containers. We put them on our private Docker registry on the Docker Hub. Now, for our OSAS broker, we developed a custom exporter which can give us some data, but we could have, and there's a lot more to be done in that area. And we have developed, based on the application, we have done different Grafana dashboards dynamically using the REST interface. There are some work that we did with the what if scenarios, but if time permits, we can go there. Now we'll go quickly to the demo. Now what you can see here is our Mass UI, where you can log in and subscribe. So this is the opening, the landing page, as you can see. Now initially we want to make sure that nothing is running, so I just wanted to show that when you see a Docker PS, you see, you don't see anything running out there in terms of services. Now, especially things like Zookeeper. Okay. Okay. Sure. Yeah. So now you can see that. Yeah. So you can go back. Now let's log in. Now that we have a clean slate, let's log in. And what it takes is a config.json file to describe how your SaaS application looks like.
So slow down a little bit.
Okay.
This is the part where people want to see the UI.
Okay. Slow down. Okay.
You're already over 7 minutes.
It's okay.
Okay, now we have the config.json cut and pasted, and so now you can see that the subscription has taken place. So now if you go and see what the script is doing in the backend, what you should be able to see is the Docker commands running in the background. It is identifying which are the service components, and it is deploying them. Deploying the exporters as containers. Now, once we have done that, we can see that the different containers are deployed for RabbitMQ, and you can see that they have been come as mass Docker. We can want to see that they're coming from the Docker Hub. So we just want to show that we have put this into the private registry. So yeah, this is the Docker Hub, where you can see some of the exporters that we have pushed there, and that can be used. Now this library can be extended over a period of time. Now let's come back to the UI and let's activate so that we can start monitoring the components that we have showed so far. Now, once you do the activate, you can see from the Docker script that it is instantiating the Prometheus and the Grafana services. Now that is one service, and there are containers for each SaaS subscriber. So you can see that it has been deployed. Now once you come back to the UI, the scraping is taking place, and Prometheus knows which metrics to pull from. And so once you come and see the Prometheus status, you will see that this is the configuration has been updated, and now you can see these are the different targets: Cassandra, MongoDB, RabbitMQ, Zookeeper, and the status is healthy. And so now we can make sure that the monitoring is indeed taking place. Now if you want to see what is the effect of the monitoring that we are doing so far, you can go back to the UI. Now you can see that, okay, the different components are listed, and within each component you can see some of the parameters which are there. Now there are a lot of parameters, there's a lot of work we can do here, but if you look at the metrics, we can see that this is the metrics that the Prometheus is pulling on a regular basis, in this case every 5 seconds. Now it's not easy to make sense out of it, but there's a lot of data coming in. But in order to make a clear visual sense, this is where the Grafana dashboard comes in.
Schedules are posted.
And so now you can see all these graphs of different components right here. This is for the Cassandra, and we can just get different dashboards like this. Now we just started the monitoring, so you can see that the graphs are slowly building up. We indeed actually have some traffic generation in the background. This nothing but the BBT scripts that we run on a regular basis, but running back to back. But as you can see, there is a lot of data, and this, keep in mind that these dashboards have been generated on the fly using the REST API, based on the SaaS application. So this whole thing is extremely flexible, and we want to keep it that way, and it's all containerized so that when the need is no longer there, it can be cleanly removed from the system without affecting the SaaS application. So that is the power of service monitoring that we talked about. Now,
Unsubscribe.
yeah, quickly we want to show how the unsubscribe works. We did do some instrumenting while subscription. So when you are unsubscribing, and if you go back, since these are containerized, it's very easy to go back and show the Docker commands for the unsubscribe. And if you look at that, it is we are removing of each and every component that we put in, leaving the SaaS application in the same state as it was before it entered the monitoring request. So and when you do the Docker PS, you can see that the system is indeed gone back to its original state, and we don't have any Prometheus and Grafana dashboards, services anymore. So this is a very yes. Now you can see that all the containers have been taken away. So this is this is a way in which you can monitor service in and out of the system. Maybe you're doing a quick performance test. Maybe you're running a specific test where you want your SaaS applications to be monitored for that duration, for that test bed, for that SaaS application, and it's very easy to do that. Now, there are many ways to go forward with this. Last slide. So, some of the things that we are thinking of, but we couldn't pull it for this session, was the fact that the alert manager rules, we have the component, but the rules wherein you can have a notification, say a particular service is slow, it is not responding for the last 10 seconds. Maybe a particular, the FDs are run out, or maybe the Cassandra memory has run out. So these kind of things can be notified. We can run this on the vCloud platform so that it can be a truly a service that everyone who has access to vCloud or everyone within the company can use it. We also want to use an automated service discovery that is supported. We want to make sure that the metrics, the user has an option to select the metrics that they are interested in. We want to make sure that a lot more custom exporters are supported, and we want to containerize the mass application service itself so that it can horizontally scale should the need come for more high-end services. And last but not least, VROps, Hyperic integration in terms of having a custom exporter. Hyperic and VROps can do a lot of infrastructure monitoring and a certain level of application and service monitoring. But I think together they complement each other very well, and it can give a good story to our monitoring service.